everyone. Hope you are all doing very well. So welcome to Falcon Design and Build Private Limited new sessions. We are going to start today. In the previous session, we have learned basics of beam structure. So BIM structures, we have seen all the modeling elements. But in today's session, we will start with proper detailing. We will go through the reinforcement inside the concrete. Means we will look fully inside the RCC, reinforced cement concrete, and we will look how the detailing going to be done inside the BIM model. And so let's start. So hope you all have gone through the previous sessions and gone through the basics modeling. Already you have worked on the BIM architecture, so I think no one has any confusion with the basics of the BIM structures, right? Because it's kind of similar only. Some of the elements like columns, beams, and even the walls, structural wall, footing, those are all you have already gone through somehow in the previous while doing the architectural elements. But again, I will show you how to work on the beam structure inside the Revit. So let's start. So already I have explained you how to start a beam structural new project. Okay. So either you can take the construction template or you can select the structural template so that you can, if you want to only work in the structural template, it is fine. Otherwise, construction template is also very much fine. Let's start with structural only. So already we have gone through all the walls and columns and some of the elements which is by default shown in the Revit, like beams. So those things we have already looked, even the footings, different types of footing. Again, I will not go in detail to create new labels and creating new grids because already we have discussed that so many times. So my main focus is to create reinforcement inside the structural elements, right? What I mean to say, like I will show you. So suppose in the previous sessions we have modeled the structural footings, right? The isolated footing, the combined footing and all we have modeled. Now we will see how the details, the reinforcement inside the concrete we have to provide inside the Revit. Okay, those things we will mainly check today. And also we will see how the codes, the Indian Standard Code, IS codes, have provided the details and how we can follow it. Okay, so that whenever we will draw the reinforcement, it should follow the standard as per Indian standard. And when you will work on the foreign projects, then you have to follow the foreign standards as well. Okay. So basically, the thing is, once you will learn the Indian standard, you will be well prepared to like work on any other standards as well. Like it's easier to understand once you will understand one of the standard, like our Indian standard. Okay. So let's start with the footing first. Okay. So you can see this is the code SP34. In the SP34, you will get all the other, like all the details. Like you can see steel reinforcement. You will get all the reinforcement details for the footings, for the foundation, for the columns, for the beams, for the slabs, stairs. So all the different steels detailing you will get inside the SP34. Okay. So let's go to the footings again. Even some of the things related to reinforcement, it is also given, which I will not explain in deep, but while doing the reinforcement detail, I will give you the basics so that you will understand the things very well. Like these are the type of uh, anchoring and whatever the reinforcement provided, those have certain bending dimensions and all, it is there. Okay, so those things I will explain you so that you can understand bending. Okay, so yeah, this is the section 6, basically start from the foundation. So basically we have to look at the diagram and we have to understand the things. Okay, so okay, so this is basically the very basic, typical isolated footing diagram. It is shown over here. By default, as you remember, I have created one isolated footing, uh, like a slab. Just we can place a slab, and we have to start working on it. So, like I will show you how to create isolated a footing. Basically, it is having a dimension like length, width, and its depth. So you can see over here we have one isolated footing which you can place. It will be having certain dimension. Another one I will place. It is little bigger one. So basically these are the isolated footing. So when you will see through the section, I will draw a section just over here. And when you will go to the section, so what you can see, there is a its depth. Okay. And also now in this section, you can see the concrete we have right now. Okay, now we how to provide a reinforcement, that is our main focus. So first of all, we have to provide cover. So cover, what is the meaning of cover? Cover means like how much we have to provide the host from the exterior, like how much we can provide the like outer concrete um boundary from the inside center of the reinforcement. So that is what we have to provide in each elements. Like in the footing we have to provide cover, even in the columns, even in the beams, slabs and stairs, everywhere we have to provide cover. Okay, so by default in footing, not by default but like as per a standard, in footing we have to provide minimum cover of 50 mm. Okay, what it actually means I will show you. When you will go to the section and when you will provide a cover and you will select the footing, it's starting selecting certain boundary. Okay, that boundary actually it means like the reinforcement should be provided inside this boundary. Okay, this dashed area. So now you can see, while I have selected the cover, there is a cover settings and there is a uh, edit cover settings options available over here. Once you will open a dialog box is open for the cover, different types of cover. So basically you can see there is as many different styles of like different dimension of covers available by default, like 15 mm cover, 25 mm cover. Okay, so what we actually need is 50 mm cover. So you can select the 50 mm cover. Okay, and don't look for these naming for now. We just need to understand the 50 mm cover we have to select. Okay, you can select 150 mm cover, or if you want, you can create your own cover also. If you don't understand which are these cover, you want separate cover for your own project. So you can just create new by clicking add and give the name footing, and you can give the value 50 mm. So minimum of 50 mm cover is required for our footing. Okay. So once you will select, you have one option and you can select the footing 50 mm. Footing 50 mm. Okay. So you can see 50 mm cover is provided over here. Same way you can select for whatever the number of footing you have provided. You can select all at a times as also, and you can provide a cover. So now once you will provide a cover, then you can start working on rebar. So you can place a starting rebar placing. Okay. So once you will click on the rebar, it will ask you like there is no rebar shape definition is available right now. So it means you have to load the rebar shapes. So where you can load the rebar shape, I will let you know now. Press OK. It is a kind of family. Basically, these are the rebar shapes. Okay. So now it's loaded. But if you have not seen in your project or it is not loading directly, what you have to do, you have to go to load shapes option. When you will select the rebar shape option, press OK and select the load shapes option. Okay. So it will open a dialog box basically for the loading families. So if you have the families available, you can open the structural rebar shape. Structural structural rebar shapes. Okay. So in the structural rebar shape, you will find so many different shapes. Select all and press open. Even go inside the Indian specific folder, select all and press open. Okay. So you will be having all the shapes available inside this project. Okay. So one by one, automatically all the shapes will be loaded. So how these shapes work, I will let you know now once it will be loaded. So you can see by default, if you don't know which shapes you have to provide, suppose I will show you the section diagram of footing. So the basic diagram of footing is kind of this, which is having bottom steel, okay, top steel, bottom steel in both direction. Like this is the one directional, the main bar, and there is another direction. Okay, in the code book of detailing SP34, there also you can see, okay, the dot one. It is showing basically other directional bar. Okay, and This one is the main bar, okay, which is the black one, dark black, okay. Now dot one is the, so basically in footing, even in the slab, in the floor, there's two bar. One is the main bar, another one is the uh, secondary bar, or that we call as uh, just a second, distribution bar, okay. So what it means, main bars and distribution bar, when the slab is having when the slab or the footing is having one side main bar, the other side will be a distribution bar, which is shown in over here in the section. The dot one, it is showing basically the distribution bar. Okay, it helps in kind of supporting the main bars. Okay, so first we will provide the main bar. So you can see the bar which I'm going to place is the 0 0. It's basically the straight bar. Okay, so once you will place over here, once you will click on the structural element, it will be placed. Okay, so once it will be placed, it is just a single bar. When you will open 3D, what you can see, it is just a single bar placed in between, because I have created a section in this direction. So basically along the section, the bar is placed. Okay, now what you have to do, select the bar and go to over the layout option. Basically what we have to do in this area, like in this call, in this footing, the bar which you have seen in this direction, it's not a single bar, it is also having certain spacing, and so many bars in this direction will be placed. I will show you in 3D so that you will get clear image. So you can see when bars are placed, it is having two directional. One is the main bar, and second one is the distribution bar. So see, this website is also taken the image from the SP34 only. And what we have to look over here. So suppose this is a plan view. Okay. So in the plan view, you can see the reinforcements are placed in the vertical direction and the horizontal direction as well. Okay. Let's see another image. So let's see over here in 3D. The red one is showing basically one direction and the green one is showing the other direction. So both are having a spacing. A spacing means from this the space in between these two red bars is basically the spacing of the main bar, and again the green bars which is in the horizontal direction, is it is also having a space in between. Okay, So you can see, yes, over here you can see basically in this square, in this footing, you can see two images are showing right now. One is the main plan view, and this one is basically showing the section, like how the reinforcement are provided in this section, this single one. Okay, and again the other side section, how the reinforcement are provided. So basically the shape of the rebar, it's basically shown in the sides. Okay, see, there is a main bar. Okay, and there is a another bar is that is distribution bar. Okay, also I want to explain, like certain times both side will be main bar, like in which possible meaning, like what is the actual meaning of main bars. First I will explain you the floor, as already you have understand, like when you have read these things in the civil engineering, like each floor is having two types of bar, like one is in the horizontal direction, one in the vertical direction. Okay, so both bar can be, both side the bars can be the main bar. Okay, but what is the definition of both side the bars will be the main bar is basically slab dimension. Based on the slab dimension, that is okay. So if the span is shorter one, then the bar will be the main bar. Okay. If the span length means the slab length. Okay. If the slab length is the longer distance, it's long. So basically that side we can provide the distribution bar. But certain time those slabs are both side kind of similar span. Like if both side the span length are kind of same, then that time both side we have to provide mean bar only. Okay, now what is mean bar and what is distribution bar, that I will explain well in the while detailing the floors. Okay, but for now I am just explaining because we require to understand how we are providing mean bars and distribution bar in the footing as well. Okay, so that's why I just explained. But you can see it is mentioned over here. It's a main reinforcement, and generally in the footing, both side will be the main reinforcement only. And what is that means? Like whatever the shape we are providing in this direction, that will be provided in the other direction as well. So that is the purpose of main bar. See here in the footing, it is shown main bar in both the direction. Both direction means the dot one is also main bar, even the horizontal one, which is shown in this figure, is also a main bar. Okay, so what I have to do, select, while placed, we have already placed the single bar. We can give the edit a sketch. and we can provide edges of 200 mm. Okay, both the side you can provide 200 mm and finish. While finishing, make sure this black curved line is drawn. Otherwise, it will occur error. Okay, because bar is having certain radius tendency to bend. So if the black line will not occur by default, then error will come. So make sure the bar is provided is having bend. Okay. Now, what is the bar dimension that we have to look from our structural engineer drawings? Okay, GFC drawings. Based on the drawing size, drawing dimensions provided from the structural team, we have to provide our reinforcement. Okay, suppose I just check one example. Let's see. Suppose this image. So this is very simple example. Here, bottom reinforcement, top reinforcement are provided. Okay, 18-inch floor means footing thickness is provided. Now, in this footing, you can see 3-inch clear cover is also provided. Cover is also provided. So what I have explained, minimum of 50 mm cover you should provide. Certain time we have to provide more cover, like over here 3-inch means around 75 mm of cover you can also provide, but it should be mentioned from the structural team, like what is the cover you can take over here. Okay. Now, the dimension of bar right now it's given half-inch dia. Okay, means 12 mm. 12 mm bar dia, spacing 6 inch. Okay, in between the spacing is given is 6. So what you have to do right now by default 12 mm bar dia I have selected. Okay, but if you want certain time 14 mm, 16 mm, or 10 mm, 8 mm, whatever the bar dia, based on that, you can select from here if it is provided in yours. And because I have selected the structural template by default, so many bar dia and so many structural elements is provided in this template. But certain time you will select different template, then these things are not available. So what you have to do, you have to duplicate and provide the bar dia at that time. Okay. Hope, hopefully you have understand these things. Okay. Now over here, the layout is which is providing a single bar. I want number of bars, maybe the maximum spacing, or maybe you can select number with spacing and minimum clear spacing. Okay. So I will generally I am preferring to select the maximum spacing. I will let you know in some time what is the meaning of maximum spacing. But I have already explained during the uh, while doing the uh, facade, we have explained these things, the spacings, fixed numbers, and all. While doing the facade, I have already provided the grids. In the grids, we have seen the spacings, right? So same way, rebars also we can provide the spacing. Okay, maximum spacing if you will select, what it will be do, it will select by default 100 mm. You can change 100 mm spacing to 6 inch or 150 mm. 6 inches generally approximately 150 mm only. Certain time it will be directly mentioned 150 mm or whatever the drawings from the structural engineer is provided. You have to follow that. Okay, they will send you the. I have just opened one of the drawings to look how the drawings structural engineer will provide to you. So like this way, they will provide the drawings and they will let you know. They will tell you to work on the details. I'm looking for the footings if it is there. So okay, footings I have not seen. Yeah, footings reinforcement details are not provided over here. But in general, I'm just explaining like this. This is the way like structural team will provide you the drawing, and they will like provide this kind of uh, language. You have to understand what is its means over here. 12 mm. This kind of symbol they will provide. It's kind of some certain time they will provide pi symbol. Okay, here kind of pi symbol only they have provided. So basically it means dia. Okay, so 12 mm dia and 150 cc means center to center spacing. Okay, suppose over here T8. T8 means 8 mm dia and T means it's a stirrups which is binding the beam. Okay, so stirrups is basically not a main bar. It's a again a distribution bar. Okay, or you can directly call it as a stirrups. Okay, which will bind the main bar. Main bar is a black one, dot one. Okay, so over here it's mentioned 2T means two. Two means on the top there will be two bar of 16 mm. Like that they will mention. So I will explain this type of drawings again, but for now I'm just explaining like this is the way they will provide you the details. Like bottom bar is 12 mm and its spacing is 150 mm center to center. So in Revit, what you have to do? You have to provide one bar and then you can select it and provide maximum spacing and give the spacing value 6 inch or 150 mm. 150 mm is fine. Okay. And then when you will see into the 3D, you will see the rebars which was placed single is provided all along the horizontal direction. Okay. And it is provided with spacing 150 mm center to center. Now this is shown very thin right now because we have not checked the fine detailing option. If you check this fine detailing option, you will see the actual dia of bar. Okay, understood? And if you will check the medium or coarse, it will not show the actual, it will just show the line diagram of the bar. But if you want to see the actual dia of bar, you can check the fine detailing. Okay, same in the section. Right now in coarse, it's showing fine, but when you will see the course, it will be shown line diagram only. And you can select the fine, then you can see the actual die of bar. Okay. Now, in another direction, if you want to provide the bar, also let's provide the bar in this footing as well. Now, once you will provide the bar 0 0, Revit will suggest you next time, like, do you want to provide this shape of bar? This is already provided over here. So basically, it will start tracking the bar diagram which you have provided the earlier. Okay. So based on that, it will suggest you to provide the different style of bar which is already available in Revit. Okay. So again, if you want to draw it from scratch, that is on you only, up to you only. But if I have option, we can select the bar. Certain time while placing bar will be not visible in this layout. What will be happening during that time? Like while placing bar, you can see there is two options available. Near to the load shape, there is placement plane. Placement plane means right now we have selected the current work plane. What it means, while placing the bar will be placed directly to the plane which we are seeing right now. Okay, what we are seeing right now, we are cutted the section in between. So while placing the bars are placed very much near to this section. Okay, if the section is not clearly visible till the end or till somewhere here, suppose it is seeing only up to here. Now once you will place the structural bar, so right now the placement plane is current work plane, means the sections is very near. But if by default you have selected somewhat near to the cover plane, then while placing the bars will be not visible. It is placing, but bars will be not visible. So you have to understand, during this time you have to see the plane you are working, in which plane you are working. Based on that, the bars will be placed. Okay. So near to and far to means, like, while placing, we are selecting the structural bar. There is two options, near and far. Near means when you are placing the rebar, it will be placed in this edge, and far means it will be placing on this edge. Okay. So when you will provide in the section, again, near means the very front end, and when we place in the current work plane, whatever the current work plane the section is cutted, exactly there the bars will be placed. Now during while placing the bar, make sure you are selecting the edge where you have to provide your bar. Since I have to provide the bar on the bottom, I have to select the bottom cover edge. Okay, if you will provide on the top, the rebars will be jump on the top side. Okay, so I have to provide on the bottom side. So click on the bottom, and then again you can select the maximum spacing. Okay, and see the 3D. So same way you can place this direction bar. Okay, now if suppose I will provide the rebar and I will provide the near cover and place. Okay, go in 3D, you will see on the near cover front side the bars are placed, but it is not visible in this section. But once you will provide the maximum spacing, and you will provide the maximum spacing of 150 mm, automatically you will see all the bars and also it will be visible in the section. So it doesn't matter like you are placing the first bar where you have to provide the spacing, okay, and then your bars are visible, okay. But obviously it's very much okay when you will placing the bars and it will be visible, then you will feel comfortable while working, okay. Now first one options you all get right: current work plane, near cover reference, and far cover reference. Apart from this, there is three more option: placement plane. So placement parallel to work plane, parallel to cover, and perpendicular to cover. What it means? Right now we are placing parallel to the work plane, right? Parallel to the work plane. By default, it's selected. If you will place parallel to the cover, you will see the bars are placing. If you are selecting this edge, the bars are placing near to the cover. If you are placing in this edge, the bars are placing parallel to this cover. Similarly, bottom cover parallel. So it is basically tracing the parallel of the cover. Okay. Then parallel to the perpendicular to the cover means if you are selecting this cover, the bars are placing perpendicular, okay, to this cover. Since we are selecting this shape, it's shown very much clearly the perpendicular, but when you will select the single sketch, that time it's very much difficult to understand whether the bars are placed perpendicular direction on or parallel direction, because certain times you have to give bar a sketch, okay. Once you will place the straight bar, you have to provide the bars, you have to extend their sketch. Just now while placing this bar, we have provided the sketch, right? So it is very much easier to understand once you will place the perpendicular sketch bar, and then you can easily sketch it, okay. See, this bar is placed and it's not seeing the this edge is not visible because we are seeing it from the section, and the bars are here. The sections is right now in between somewhere, so it is basically not shown till the edge, it's shown in between only. But when you will extend the section till the edge, you will clearly see the long end of the bar, okay. If you will not provide till this end, the long end will be not visible for this bar, okay. Understood? Any problem, anyone? I'm explaining this all to you because you have to understand these things and you have to work uh, in the upcoming session. You have to show all these things like you have understood, like you have to do your own practice, okay. Now this bars which I have placed just now, it's basically clashing in between, so this is not a right way. You can see the other bar should be placed just over the bottom bar, okay. So how we can provide the over side of this bar? You have to drag manually and you can place it just over it, okay. Because on site the bars will be placed just over the another bar, okay. So this is how you can place. Also, this bar is just now not, it's up to very much height which we have not provided. By default you can provide by either you can provide 200 mm up to 300 mm, certain time we can provide, but this much length we will not provide for the footing. Edit a sketch, See, this is right now 344. It's not mandatory and it's not required to provide this much. 250 and certain type 200 also. So basically it's provided from the structural drawing only, like how much is necessity to provide this bar length, extend extended length of this bar. Okay, same way for the other direction, you can give us another section. And this in this section, you can edit the sketch of this bar. Okay. Similarly, in this direction also the bars should not be clashed each other. So make sure you can provide one side bar is kind of this. Okay. And other side, don't move again this bar. Move the other bar. Okay. In this way, the bar should be placed. Like the bottom bar I have pull in this direction and the here the top bar I have pull in this direction. Okay. So that there will be equilibrium. Same way in the another section as well. But before that, we have to give the maximum spacing for this bar. Maximum spacing again 150 mm or whatever it is provided, like 200 if it is provided, then provide 200 mm spacing. So select this bar and pull it from this side. Also, it is required to pull little more so that it will not clashing in this edge. It will be freely provided over here. Okay. And this bar from the other end you can pull. Hopefully you have understood these things very well. Understood everyone? Let's see it in 3D. So you can see all the bars are not clashing each other and it's placed very much well inside the footing. If I press shaded view or hidden view, then the bars are not visible. Why? Because bars are inside the concrete. It is visible in the wireframe. Okay. Or the other option is when you are selecting the 3D view or shaded view, that time what you can do, select all the footing and provide override by element or provide by category. Provide a transparency to the concrete element. You can provide like 50% transparency and press OK. So you can see your reinforcement inside the footing. Also, you want to see the rebars color just like it's shown in the Google's. So you can provide your rebar color by override color. Right click, override by element. Okay, provide the surface, surface pattern, surface color. Provide the red color. Okay, so like that, you can see your rebar. Understood? And you can also show it in your LinkedIn so that you can show your profile like you have learned these things. Okay, understood everyone? So this is the footing bottom bar. Again, if you want to provide the footing top bar, no need to provide one by one again, like the top bar in this direction, other direction. What you can do, you can select the bottom bar and mirror it from the center of the footing to the top direction. Okay, while mirroring it, the things will have certain, there will be certain problem. Like what problem? You can see certain bars are clashing. So make sure again you can bring the bar little inside. Okay, the things are fine only. Okay, so this is how your bars will be there. No bars will be clashing each other, and each bar is having spacing 150 mm center to center. Okay, understood everyone? Now you can provide the color if you want, but if not required, just let it be like this. When you will, this is just a simple footing. Now when you will provide the matte footing, what you will do, suppose you have a matte footing like this, soft foot. So provide little more thickness, suppose 300 mm. Over here, same way, like this we have provided, we have to provide in this floor also, like the matte foundation. But certain time what will happen in the rough footing, there will be certain gaps. Suppose this is how the rough footing provided. Okay, so when you will provide the reinforcement, till here it's fine. Like I will show you, go in section or extend this section. So what you can do, suppose you are providing a rebar. First provide a cover. Cover is 50 mm for this footing as well. Then you will provide a rebar. Rebar parallel to work plane, near to the work plane. Okay. So you have provided like this single bar. What you will see, what you will notice, the bars are provided over here. It's a single unit. When you provide a maximum spacing, give 150 mm. So it's provided maximum spacing of 150 mm. But what you have noticed now over here, the bars, because of this edge, the bars are clearly provided over here. But from this end, the concrete is in this direction, which is having no bars. We have to extend the bar in this direction, but obviously when you will increase the length of bar, certain bar will be outside this space, which is not good, right? So what we can do, anyone have any suggestion to me? What we can do in this scenario? Anyone? Yes, Subham?
सर,
Yes,
मैं ये कह रहा था कि जैसे एल जो दे रहे थे आप डेवलपमेंट लेंथ, तो वहां पे ना एक थोड़ा
yes,
सा बैंड हो रहा है। अब
yes.
अब बैंड जब हो रहा है सर, तो हमारा अगर ड्राइंग में 200 mm अगर वहां पे सर एज पर ड्राइंग के हिसाब से रिक्वायर्ड है, तो एज पर हम जो फील्ड में जाएंगे सर, अगर मैं ड्राइंग अगर किसी को प्रोवाइड करूंगा, तो अगर मेरे से कोई पूछेगा कि एल में कहाँ से पकड़ूं, तो उस जगह पे मेरे को क्या करना चाहिए सर, एज पर आईएस कोड?
एज पर आई एस कोड एक बार चेक करना पड़ेगा, बट मेरे को जहां तक पता है सेंटर से लेना चाहिए। और क्योंकि ये चीज साइट पे ही पता, मेरे को भी मैक्सिमम तो मेरे को यही आइडिया था, सेंटर से मेजरमेंट लेना है।
अच्छा।
हाँ, बाकी एल एज पर आई एस कोड
क्योंकि
चेक करना पड़ेगा।
क्योंकि सर ये
एज
मतलब हमारा इसी हिसाब से हमारा तो बीबीएस भी निकलेगा।
हाँ,
उस हिसाब से हमें कैलकुलेशन करना है, इसीलिए मैंने ये पूछा।
ओके। ऐसा तो देना चाहिए, हाँ, कोड में होगा। जनरली क्या किया जाता है, हम लोग बॉटम से ही लेते हैं, कवर को छोड़ के जहां से मेजरमेंट लेंगे वहीं से। ओके, कवर 50 mm है, उसके बाद वहां से ले लेंगे डायमेंशन।
सर सर अगर वहां से हम लेंगे तो 2x2D जो हम लोग लेते हैं ना सर, 2D लेते हैं, तो
हाँ,
उसको भी तो माइनस करना पड़ेगा सर।
भी तो करना चाहिए। सेंटर से ही लेना चाहिए मेरे को लगता है, क्योंकि सेंटर से ही हमारा वो मेजरमेंट होगा।
हम्म।
क्योंकि कवर भी दो तरह का कवर होता है, एक क्लियर कवर होता है, एक
नॉमिनल कवर
सेंटर से
होता है।
होता है। हाँ,
हम्म।
तो सेंटर से ही लेना चाहिए। बाकी वो जैसे यहाँ पे भी, जैसे देखो एक ये जो एल एल डी टी दिया हुआ है, इसका दिया है डेवलपमेंट ऑफ कॉलम का दिया हुआ है। तो ये देखो, ये अगर जैसे ये एल डी सी है, ये बेंड, जहाँ ये देखो बेंड के बॉटम से ले रहा है, तो मेरे को लग रहा है वो भी बेंड के बॉटम से ही लेंगे।
हम्म।
ठीक है, अब वो कंफर्मेशन के लिए मेरे को देखना पड़ेगा, मैंने नोटिस नहीं किया था ये चीज। ठीक है।
लेकिन सर वो वहां पे एक बार दिखाइए, एक बार उस, हाँ यहाँ पे देखो सर, आप 150 mm जो मिनिमम थिकनेस लिया है ना सर, ये
हाँ।
दूसरा चीज है, ये आइसोलेट फुटिंग ऊपर का कास्टिंग
नहीं,
कवर है,
वो
ये देखो
वो
सर।
तो मैं बताने के लिए बस बता रहा था, जैसे ये
अच्छा अच्छा अच्छा।
हाँ, ये कर्व ये हो रहा था, कर्व के बॉटम से ये डायमेंशन ले रहा था, बस उसके लिए मैं बताया।
हम्म।
ठीक है।
सेम चीज मतलब ये क्या है ना सर, कि जब हम आइसोलेट फुटिंग में जब हम जाएंगे तो हमारे को जहां तक लगता है कि ये कोई पकड़ेगा नहीं, क्योंकि ये छोटा छोटा फुटिंग है सर। जब हम राफ्ट वगैरह
हाँ
में जाएंगे सर, वहां पे डाया हमारा हायर रहता है, 40 का रहता है, 35 रहता है, सॉरी 32 रहता है, 36 भी
हाँ
रहता है। तो
हाँ
उस
हाँ,
जगह पे सर ये चीजों को ना थोड़ा थोड़ा चीज को सर बहुत बड़ा बन जाता है, इसीलिए मैंने ये सवाल किया सर।
करेक्ट। तो वहां पर
हाँ।
थोड़ा एक्सपीरियंस, कोई साइट इंजीनियर होंगे भी, तो वो लोग तो ऑलरेडी बताएंगे ये
ये
सारा चीज।
ये मैंने पूछा था अपना सीनियर लोगों से भी कंसल्ट किया था सर।
हाँ,
तो
तो उन लोगों ने भी अप्रोक्सीमेटली बताया।
नहीं, उन्होंने उन्होंने ये बोला कि यार ये सवाल बहुत चौंकाने वाला है, मतलब हमने भी पहली बार सुना। तो सर
हाँ,
हम
क्योंकि
जब
ये हाई
एल
स्कोर में भी ये नहीं मिलता, ये एक सब एक्सपीरियंस जिसको होगा वही बता पाएगा।
हम्म।
साइट पे ज्यादा बड़े बड़े प्रोजेक्ट में फुटिंग में जो काम किया होगा उनको ज्यादा आइडिया होगा। बाकी अगर मेरे को पता चलेगा मैं बताऊंगा।
ओके
ठीक है।
सर।
अब ये यहाँ पे वापस आते हैं, लाइक वी वी आर प्रोवाइडिंग द reinforcement in this direction. Now we have certain area space left. So what we can do over here, we can bring the first reinforcement inside this area only. Okay. What we can do now, we can copy this groove, this whole groove, because it's having the spacing of 6 inch. We can copy it and provide it to this corner, and make sure once you will provide it, you can move it to 6 inch away from this corner, or 150 mm, whatever. And then you can bring it inside the cover. Make sure to bring it inside the cover, and then extend it inside in this area. Extend it. Okay. Now, one issue is here. This you can provide it this end, up to this end only. This rebar you can move it 6 inch away from this corner, 150 mm away from this corner. Okay, and bring this, draw a small detail line so that you can measure the 6 inch from this, or 150 mm. Why I'm drawing it? So that you can bring the other edge perfectly on this 150 mm away from this edge. Okay, and then other side, no need to copy it from here. You can copy it from here as well. Okay. So this is the way you can provide the reinforcement in raft footing, which is having certain different shape. Certain time you will find the raft footing is having certain bore wheel, or certain area, like any type of raft footing, because this is not mandatory like the raft footing will be like this. You will see a lot of raft footing in this manner also, because see, while doing the raft footing, mat footing, the concrete wastage of concrete is also happening sometime. Okay, suppose in the raft footing the columns are coming on the very much corner. So certain time what engineers will do, they will eliminate some of the area from the footing so that there will be less concrete, and obviously they will do cost cutting certain time. Okay, this is just one example. I'm not going for actual dimension, just I'm showing one example. Like certain time they will, for the ease of, like they will do certain cost cutting, and they will not provide in between certain portion or certain corner, they will not provide the rebar. So again that time you have to do rebar in this manner only. Like in this position, what you have to do, you have to create how many number of group. One group is over here, second group is over here, and third group is basically in this small corner, and fourth group is again in this small corner. So this is basically in one direction, and in another direction what you have to do, one group from this end to this end. Okay, then second group is from this end to this. So, and third one is this, and fourth one is this. So basically, you have to treat this big raft footing, which is having certain hollow shape inside here. You have to treat it in four different slab. Okay, understood? Or you can say four different uh, isolated footing, which is combined in between. Okay, so the horizontal will go all along this, but the vertical will go one side, it is from all along this, and another side it's small place till this end only. Suppose for this I will do the horizontal reinforcement also. So this time what I will do, I will not provide it from the section. I will do what I will do, I will provide it, I will rotate it. While rotating, I will also do copy. So when you will rotate, the copy of element will be saved. So rotate it from 90 degree. So other direction bars are safe. And this direction bar, I'll pull it over here till this end of cover. Pull this one is till ending this. Okay. Fine. You will see the actual rebar whether it is clashing or not. So if you will turn the fine detailing, that will be very much fine. Okay, now from this end to here, we can't provide it like this. Okay, copy it, place it in the corner. Make sure the spacing from center to center will be 150. So move it properly 150 once you will place it on the another bar. Okay, then pull the other side edge to the cover end and pull this end also to the cover. So once you have provided over here, you can copy it and place it in the other portion of here. Understood, everyone? So this is how you have to provide your footing. So this is the bottom one. Same way, select all the, make sure you have selected all the bars of bottom and you can mirror it. No need to provide separately the top one. Go to the section. Make sure unselect the footing. Only select the rebar and mirror it in the horizontal direction from the center. After that, you have to again do certain adjustment and provide. So those things you can do later on also, but make sure to provide both sides, the top and bottom. Hope all you have understood how to provide the reverse in footing. Understood, everyone?
Yes, sir.
So this is how you can provide the footing reinforcement. You can also see the footing reinforcement for the combined footing. Okay, same way like I have shown it for the raft footing. Same way for the combined footing you can provide. Okay. Now once the combined footing you will do, you are also able to can also work on two more footing. Like one is a pile foundation. Okay, I will show you how to do. First, how to place a pile foundation. Load family. Structural footing. Structural foundation. Okay. So these are certain piles options available. So see, these are the piles foundation available. Okay. So whatever the number of piles required for your project, based on that, you can create your pile foundation. Okay. In the pile foundation, the top pile cap will work like similar like a raft footing. Okay. Or isolated footing. So the top pile cap, these are the pile caps. Okay. So in the pile cap, you have to provide the rebars. Now what you will notice, these are the diagram of certain pile cap. So main bar and horizontal bar, it will be similar to the raft footing. But in certain diagrams, see for the three pile, which is shown in this direction, in this image, is provided with the rebars. One rebar is started from this end, then it is decreasing at every segment. How to provide this type of rebar, I have to show you so that you can understand. So provide rebar. So create a section first. Okay. So this one is one of the pile. Provide a cover. So see, once you will provide a rebar over here, then you can turn the top direction. Certain time it will be 250 or 300 also, based on the depth. Okay. Now what you have to do, if you will provide the maximum spacing, software will only provide till this end, because software will not understand what will we it has to do after this end. But there is one option, varying spacing. Once you will provide the varying spacing, varying spacing is not okay. Okay, let's provide another one. Okay, so in this scenario, you have to place some of the bar manually. How? You can do copy, place it over here, press wireframe so that you can see the bar, and unselect the maximum spacing, select the single bar and place it at 150 mm and bring it till this end. Okay, similarly in this direction as well. Copy and place it 150 mm. So maximum spacing of 150 mm, what it will do, it will not provide the maximum of 150. It will be showing like how much we can adjust so that it will be not 150 accurately. So one by one you have to drag the end. Okay, I'll provide one more. Okay, so once it will be done, select all these bars from the corner and mirror it from the center. Okay, so in this direction you have provided the bar. Similarly, for the other direction, you can also provide. This is working over here. See, I have provided the varying bar, but the varying bar, it will work only when the group is separated from the horizontal area. It should be placed in the tapered area. Okay. So this group basically I have provided separately. So this also you can do same in the same way. We'll try to do again. So select this one. Already selected the varying bar, maximum spacing. Yeah. So this is working very well over here. So maximum spacing of 150 mm. Okay. And then you can adjust little more. Similarly, these elements I will delete. I will mirror it from the center, this group. Okay. This one is a single group only. So once you will provide the varying element away from the horizontal area, it will start working. Okay. So this is how you can provide bars in this kind of shape. Now for the pile, what you have to do, you have to provide the pile for putting rebars as well, pile foundation. For the pile, there is a rebar shape of spiral. So this is not working here. Let's do one thing. So right now I'm in 3D. Basically, again, you have to measure the cover of 50 mm and then you can provide. But just now I have provided. And this is a spiral type. So certain time the spiral bar for the pile we are providing and certain time I will show you certain images, file foundation detail. Okay. So certain time spiral. So like this, you have to provide spiral rebar. Okay, with vertical reinforcement as well. Now there is a pitch, which means how much this one corner spacing is. So this we can provide 150 again, so that it will be more spacious. Okay. And certain time there will be a normal circular, which you have already seen. Certain time show you, but in that the spacing will be center to center. I can show you some image. Yes, this one. So if you can see over here, there is separate circle, which is a stirrups provided at certain spacing. So that one also I will show in one. Other than that, there will be vertical stirrups, so that you can provide with the straight one only. Structural rebar, parallel to, perpendicular to the cover. Now, stirrups are generally not provided with 12 thickness dia. There will be like 8 certain time 10 8 is also fine. So stirrups are very much thin, but mean bar will be having more dia. 12 15 16 20 okay? Like that, the mean bar will be there. I'm copying it based on how many numbers is provided. Okay, so this is how. Make sure to provide it till the bottom. And also in the bottom, you have to turn it if it is shown. In the top, you have to bend it like this for each rebar. You see, there is a development length of 450 mm provided in the cap. So that you have to do for each rebar. Before copying, what we can do? We can do sketch of one. Edit a sketch. It's provided till here. Suppose this one there is no. Yes, it's LDC. Till LDC we have to provide this development length. Okay. So whatever the LDC of pile, basically the same LDC is for the column development. Okay. So that we have to provide for the pile as well. So suppose this is done here. Was 450 or 400. Since this footing is not too big, I'm providing on 400. And once it is done, I will delete this one. I'll mirror this to the other side. Okay. And then select this to these two are a sketch. I will delete this all because I will provide it again. This two and rotate it while copying. So rotate it from center, provide at 45 degree. Okay. Again, select this two and these two. So like this, you have to provide your rebar. Now see, one rebar is out of this footing. So make sure when this things is happening, no need to provide outside the cover. Okay, bring it inside, or certain time we can bend it in the cover edge only. Okay, so these things you must have to you also have to follow. Okay, understood everyone? Any doubt? So start working on it. I will not go for the other things. Only footings and pile foundation I have covered today. For the next session, we will cover columns, and then maybe we will proceed to beams as well. And then the final session, we will take slab and stairs. Okay, understood everyone? Any question till now? Don't worry, if you have any query, you can bring it later on also. But start practicing, keep on asking the question in the group, and discuss to yourself as well, okay, in the group, so that I can see you are doing the practice. I'll provide one project, and for now you can do the practice. I will provide this SP34 handbook detailing code book in the group, so that you can follow this and start working on this, guys. Have a nice day. Thank you, everyone.
Thank you, sir.